So the chi-square figure is your summation of your frequencies observed minus your frequencies expected. You square that figure and divide it by your frequency expected. Okay, you have to do that for every frequency observed and the corresponding one expected. Then you add all those up, and that will be your chi-square final figure. Now, remember, we have 12 numbers here in our observed frequencies as well as in our expected frequencies. That means we have to do, for this particular problem, 12 calculations. Right? So here we have 89. Right? Instructor A had 89 people who said his or her class was very valuable. The expected frequency is 93.8. So we take the frequency observed of 89 minus that frequency expected of 93.8, square that difference and divide it by the expected frequency of 93.8. You can see we've done that right over here. 89 minus 93.8, square it, divided by 93.8, and you get the figure of 0.246. So getting the chi-square takes a long time. You have to do that 12 different times for each frequency observed with the corresponding frequency expected. And as you can see here, we have those 12 calculations done for every frequency observed and expected. If you take all those 12 figures up, take all those 12 figures and add them up, you get your chi-square of 17.79. Okay, and at this point you're almost done. You just have to take that figure and place it in your table to see if it reaches statistical significance. Now that we have our chi-square figure, we have to figure out our degrees of freedom. To calculate the degrees of freedom for the chi-square problem, you take the number of your rows and subtract 1 and multiply it by your number of columns and subtract 1. Now for this problem, we only have 3 columns. Okay? The total does not count. Likewise, the total does not count for your rows. So we have 4 rows. Right? That means if we do rows minus 1, that's 3, times your columns minus 1, that would be 3 minus 1, or 2. So 3 minus 1 times 4 minus 1, or 2 times 3 equals 6. Okay? So your degrees of freedom for this particular problem is 2 times 3, or 6. So now if you look in your Appendix D, you have the distribution of chi-square. And I've recreated a small portion of the table, but you can see on the left-hand side you have your degrees of freedom going down from 1 all the way to 10, and it goes further in the actual table. Okay, but just so you understand how this table works, if we're looking for our thresholds of statistical significance, we can see as we go along the right-hand row at the very top, we're interested in the level of statistical significance at 0.05 and 0.01. Okay? Now if you had a degrees of freedom of 1, then your chi-square would have to be bigger than 3.841 to be statistically significant at 0.05, or bigger than 6.635 to be statistically significant at 0.01. But we have a degrees of freedom of 6. So if you go along that row, you can see that in order for our frequencies observed to be statistically significant, or our chi-square figure to be statistically significant at 0.05, we need a figure of 12.592 or higher. Now remember, our figure was 17.79. So we know that it's statistically significant at 0.05. And 17.79 is bigger than 16.812. So our frequencies observed and our chi-square figure is statistically significant at 0.01. That means the frequencies observed in our original table are unusual. In fact, if you go back and look at the frequencies observed, you can see that instructor C had an unusually high number of students proportionally who said his class was very valuable in comparison to instructors A and B. Okay? That unusually high number of students who said instructor C's class was very valuable was so different that it reached statistical significance at the levels of both 0.05 and 0.01.